Okay, so we still have to find the, just a reminder, what we're doing is we're finding the unit vector for TAC. So right here I've done dx and dy for vector TAC. So next we need to do dz. Oh my goodness. Okay, let's try that again. Okay, so dz, and we're looking from the endpoint, that would be -10. Okay, minus 0. So dz is pretty easy. We're just going to do a -10 there. Okay, so now what we need to do is figure out the shortest length from A to C. Okay, so DAC is going to equal the square root of 1 point. That looks more like a comma there. 1.2 squared plus 10 squared plus 10 squared. Okay, so when we do all of that, let's see, DAC is going to be plus 10 squared plus 10 squared, 14.2. Okay, so DAC is going to equal 14.2 meters. Okay, so to find the unit vector, oh gosh, okay, let's do that again. For AC, okay, all we're going to do is take that negative 1.2 and divide that by 14.2. And that's going to be hat plus 10 divided by 14.2 j hat plus 10 divided by 14.2 k hat. So our unit vector okay, we're going to get a negative 0.085 I hat plus 0.70 j hat plus 0.70 k hat. Okay, so now what we can do is write in Cartesian vector notation for TAC, we're going to have a negative 0.85 times TAC I hat plus 0.70 times TAC j hat plus 0.70 times TAC k hat. Okay, now that we have both of those vectors, we know that the sum of all of them have to equal 0. So if we do, let's take the x direction first. Sum of the forces in the x direction have to equal 0. So I'm going to take all my I components of both vectors. So that's going to be a negative 0.933 times TAB minus 0.85 TAC, and that all has to equal 0. Okay, we're going to do the same thing for the y. Sum of the forces in the y direction have to be 0. Okay, so, oops, I forgot one. Let's see, we forgot the p vector. So we forgot plus p equals 0. So notice I have 3 variables here. Okay, so I'm going to write equations for the sum of the forces in the y direction are going to equal 0. Okay, so if I look at TAB, the first one for the y direction is 0.778. Okay, and then for TAC, it's going to be plus 0.7. Okay, P doesn't have any variable here, but I do have a minus 1,962 newtons from the weight. Okay, we're going to do one more. That's for the Z. Sum of the forces in the Z direction have to equal 0. Okay, so Z direction looks like we just have 2. So we're going to start with 0.8 TAB plus 0.7 TAC is going to equal 0. Okay, so now notice I have 3 equations and 3 unknowns. If I wanted to, I could definitely do substitution to figure out all of these, but why? So here you can do Cramer's rule. I'll show you really quick the setup for Cramer's rule. I'm actually going to do an RREF here. Let's do Cramer's rule right here. Okay, so we'll do Cramer's rule. Okay, so remember, I'm going to take the number that's in front of each variable for each equation. Okay, so that here I would have a negative 0.933. This one I'm going to have a let's see, a negative 0.085. And P is just going to be 1. Okay, on the next line, I'm going to have all the Y's. So the TAB is going to go first, so I'm going to have 0.778. Okay, and then here I'm going to have 0.70, and here I'm going to have a 0 because there's no P. Here I'm going to have a 0.8. This here I'm going to have a 0.70, and then here I'm going to have a 0. Okay, so using Cramer's rule, this is what I'm going to do. Okay, I'm going to use an RREF. So I am going to make my augmented matrix. Okay, so my numbers are going to be the same. 0. A negative 0.933, and I just take each equation. So for x, the sum of the forces in the x direction, negative 0.933, then I have a negative 0.85. Oops, that should be a 0.085. Oops, I wrote that wrong over there. Okay, negative 0.0, not two O's. 0.085 and a 1. And then over here is going to be my, and then I'm going to have a 0 because that's what it's equal to. Okay, next row. Sum of the forces in the y direction. So I'm going to have a 0.778, a 0.70. Here I'm going to have a 0 because there's no p's, and this is going to be equal to 1,962. Okay, next equation is the sum of the forces in the z direction. So I'm going to start with 0.8. This one is going to be 0.7 again, 70. I have no p's, and it's equal to nothing. That is what my augmented matrix will look like. Okay, so I'm going to do an RREF on that, and what you should get is P is equal to 235 newtons. TAC is going to end up being 1,402 newtons. Oops, TAB, sorry. Okay, and then TAC is going to equal 1,238 newtons. Okay, so this is where that RREF, that reduced row echelon form, or your Cramer's rule comes in, okay? Because you've got some of the forces in the x, so you have an equation for that. Some of the forces in the y, you have an equation for that. And some of the forces in the z, you have an equation for that. Okay, so we'll stop there for chapter 2. Hope this helps you through it, and I'll probably be putting up some more examples tomorrow and get those videotaped for you. All right.